Welcome to The Explainer. Today, we're diving into a machine that can carve steel with microscopic precision, the CNC mill. But here's the thing, with that kind of power comes a serious set of rules you absolutely cannot break.
Yeah, this is a CNC mill. It can shape hardened metal with unbelievable accuracy. But make no mistake, the forces at play here are just immense. The cutters can shred skin, muscle, and bone in an instant. This kind of power demands your absolute respect.
So you've got all this power. How in the world do you control it safely? Well, it's not just about knowing which buttons to push. It's about developing a mindset of total awareness before you even think about turning the machine on.
Okay, so first things first, we've got to learn to speak the machine's language. Understanding these key components is the very first step to operating it safely.
Think of it like this. It's a super smart, computer-controlled robot for working with metal. It just follows a program, you know? It doesn't think for itself. And that's exactly why the operator's preparation is so critical.
This right here, this is the heart of the action. It's where the tool actually meets the material. And yeah, it's where all that incredible precision comes from, but it's also the source of its most immediate dangers.
And you see that big box around it? Think of that as the machine's armor. Those plexiglass doors, they're not just there to look pretty. They're literally designed to stop workpieces, clamps, even broken tools from flying out and hitting you.
All right, so we've got the basic parts down, but now let's talk about the single most important safety feature of the entire setup. And guess what? It's not actually part of the machine. It's you, the operator.
Okay, pop quiz time. This is straight from the official safety exam. What do you think? Is it okay to wear gloves, jewelry, or loose clothing while you're running one of these? I mean, it sounds a little weird, right? Aren't gloves supposed to keep you safe?
The answer is a huge, absolute no. And here's why. A spinning tool won't just snag a glove or a sleeve. It'll pull your entire hand, your arm, right into the machine with it. This is one rule that has zero exceptions. Ever.
And it's not just about what you're wearing. Your own personal readiness is non-negotiable. You've got to have approved eye protection, always. Long hair has to be tied back. And the work area, that is a zone of total focus. Distracting an operator is incredibly dangerous.
So, before a single watt of power is turned on, a skilled operator does what's basically a pre-flight check, just like a pilot, every single time.
You know, the first sign of a professional is a clean and clear workspace. Any loose tools on the table can become projectiles, and coolant spills are a serious slip and fall hazard. You see it, you clean it up. Immediately.
Okay, now this might be the single most common mistake, and it can have some seriously catastrophic results. If the machine starts with this vice handle attached, it becomes a projectile with enough force to shatter the safety door. Always, and I mean always, remove it.
Think of the coolant like the oil in your car. It's the lifeblood of the machine. It lubricates and cools the entire cutting process. Running the pump dry because the level is too low? Well, that can cause some very expensive damage.
All right, so all our pre-flight checks are done. Now let's cover the rules of engagement for when the machine is actually running and that spindle is spinning. So all those little metal shavings that come off, they're called chips. They aren't just messy. They are razor sharp and can be scalding hot. Reaching in with your hands is a guaranteed way to get a really nasty cut.
And that's exactly why you never use your hands. A simple brush like this is the only correct and safe way to clear that machine table.
Even just loading a tool has a very specific, safe technique. The cutting edges are sharp, of course, and there's a big pinch point between the tool holder and the spindle. So using a rag and keeping your fingers low, below the flange, protects you from both of those hazards.
Pay close attention here. If this alignment is off, the tool isn't securely seated. And at thousands of RPM, it can become another high-speed projectile. The fit has to be absolutely perfect. Look, even with perfect preparation, things can still go wrong. A tool could break, a workpiece could come loose. You need to know exactly how to react when that happens.
You see this big red button? That is your absolute first line of defense. Any unusual vibration or strange noise is a sign that something is seriously wrong. Don't hesitate. You hit that e-stop. It cuts all power and stops all motion, instantly.
Now this button is a little more nuanced. Feed hold is used to pause the program so it stops the table from moving, but, and this is important, the spindle keeps on spinning. It's useful for checking on something mid-operation without having to restart the entire machine.
At the end of the day, these rules aren't just suggestions, they are the final exam. And the passing grade isn't 90%, it's 100%. In a machine shop, there is zero room for error.
You know, once these rules become second nature, a dangerous machine is transformed into a tool of incredible creation. Respect for the power leads to mastery of the craft. Safety isn't a limitation, it's the foundation that lets you build something amazing.